in the scenario of these, I mean, either small language models or vertical models that you're referring to, and somewhere ought to fine tune them, right? Do we have a sense of what kind of training data is needed to fine tune them? Is it 100 instances, 500 instances, 10,000 instances to fine tune something to be good enough? Do we have a sense of that, the order of magnitude of the training data?
So in this case, there's actually a mix of both, right?
Mm.
Just having more data isn't enough. I mean, I can have like 5 billion instances, and they can all be garbage, right? They can all be like small like modifications of the same instance. So it's really important to have the right data and also have enough of it, right? Now, of course, it depends on the use case, how what is enough, right? For example, if you take an e-commerce example where you have, let's say, the Amazon taxonomy of a vast taxonomy of, like, let's say, 10,000 items or top nodes, right? Or 10,000 categories or more, right? So you would assume that, yes, in that case you would need a lot of data to cover the whole umbrella, right? So just by the nature of the fact that Amazon has over 50,000 categories, you can assume that that's going to require a lot more data than a use case in healthcare, where you're doing like a breast cancer classification. Well, it's not that easy to obtain a data set for breast cancer diagnosis, because it's limited by the number of people you have in the world. So there's a scale difference there, but at the same time, there is always a need for more data all the time. And this is where a new space, well, not a new space, a space that's becoming more prominent, is how to create synthetic data, right? How can we create artificial data to help us overcome this bottleneck? So that's a space where a lot of work is now going on. How do we create proper like artificial data that can help us accelerate this?